Okay, first and foremost, I apologize for how late this video was getting put up. I lost my iPad and yeah, I apologize for that. So I'll talk to you guys about it tomorrow, but let's talk about probability, because probability is something that you are going to see on the ACT. It pops up a lot. Like when people ask you math questions, probability is one of the most common. So probability is the measure of how likely an event is to occur, and the set of all possible outcomes is called the sample space. For equally likely outcomes, the theoretical probability of an event, P of E is what they usually would say, is the ratio of the number of favorable outcomes to the total number of outcomes possible. Okay, so let's do some simple ones. So a jar contains 32 red marbles and 28 blue marbles. We want to know the probability that a randomly selected marble is red. Well, the total number of marbles in this jar is 60. So if we want to know the probability that it's red, well, there's 32 red marbles, so it's going to be 32 out of 60, which reduce that. You get 60 out of 30, which is 8 out of 15. So the probability is 8 out of 15. Okay. Probability that a letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So a vowel, that's A, E, I, O, U. So there's E, 1, 2, 3, 4, 5. So that's going to be 5 vowels, 11 total letters. So that's 5 out of 11. Okay. What's the probability of drawing a heart in a club from a standard deck? Well, remember, so if you think of a deck, there's 52 cards in a deck, and there's 4 different suits. So there's 13 of each, and there's hearts, clubs, diamonds, and spades. And they go from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's jack, king, and queen. So the probability of drawing a heart or a club, so the probability of drawing a heart would be 13 out of 52. Or a club, which is also 13 out of 52. So 13 plus 13 is 26, so it's 26 out of 52, which is 1/2. Okay, we're going to skip that one. Okay, let's look at this one. So the complement of an event. So the complement of an event is the probability that the event does not happen. Okay, so it's the probability of the event not happening. Since all the sum of the probabilities in the sample space is always 1. So no matter what, the probability of something happening is 100%. Okay, so the probability of the event not happening, whatever you want it to be, is just 1 minus whatever that event might be. So if we look at this one, the probability that it will snow tomorrow is 7/20. What's the probability that it will not snow? Well, the probability it will snow is 7/20, so we're just going to take 1 minus 7/20, which is 20/20 minus 7/20, so 13/20. Okay. A month of a year is randomly selected. What is the probability of getting a month that does not begin with the letter A? Well, there's only 2 that begin with the letter A, August and April. So that would be 1 minus 2/12, which is 10/12, which is 5/6. Okay, if a spinner is spun to the left, we want to find the probability that it lands on a number that is not prime. Well, let's think about prime numbers. So the prime numbers we have here, 1 is not prime. Because to be a prime number, it has to be only divisible by 1 in itself. Well, since 1 is itself, that kind of breaks the rule. 1's a special number, so 1 is not prime. But 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, and so is 13. There's a total number of 16 numbers there, so that's going to be 1 minus 6 out of 16, which would be 10 out of 16, which is 5 out of 8. Okay, I actually don't want to skip this one. I'm going to do it on, I'm just going to pull this up real quick. So what it's saying is we have 2 dice, and we want to know the probability of not rolling doubles. No doubles. I think that's what it says. Oh, whoops. Well, dang it. Okay, I'll do it again. So 2 dice, probability of no doubles. Well, let's just think about this for a second. So let's draw out all our possibilities. It's not going to take as long as you think. So on the first dice, we could roll a 1. And you could also roll a 1 with that, so that's a double. Or you could roll a 1 and a 2, or a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Okay. Or on the first dice, we could have rolled a 2 and then rolled a 1. And then 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Same thing with the 3. We could have done 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. Same with the 4. 4 and 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Same with the 5, 5, 2, 5, 3, 5, 4, 5, 5, 5 and 6, or 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so those are all of the possible outcomes. Now we can see here that the ones that are doubles are these ones. Right? Those are our doubles. So here we have 6 possible outcomes, 6 more, 6 more, 6 more, 6 more, 6 more. So there's 36 possible outcomes. The doubles here, there's only 6 of the doubles though. So the probability of rolling doubles is 6 out of 36. So not rolling doubles would be 1 minus 6 out of 36, which would be 36 out of 36, so that's 30 over 36. Well, that reduces to 5, 6. That's a 5. So 5 out of 6. Okay? Okay, now compound events, so independent events. That means that the outcome does not affect the other outcome. That would just be probability of the first thing happening times the probability of the second thing happening. Now, if we want to know the outcome, that one dependent one, so this means that it does affect it, that's the probability of the first one happening times the probability of the second thing happening after the first one has already occurred. Okay, so let's get to these ones. These are independent. So a die is rolled 3 times. We want to know the probability of getting 1 on each roll. Well, the probability of getting 1 the first time is 1 out of 6. The second time would be 1 out of 6. The third time would be 1 out of 6. It doesn't matter if I got it the first time. My probability stays the same. So that's going to be 1 out of 216. If we look at this one, a coin is tossed and then a day of the week is selected. We want to know the probability of getting tails and then a day starting with the letter T. Where the probability of getting tails is 1/2. The probability of a day starting with T, well, there's only Tuesday and Thursday, so that's 2/7. So 1/2 times 2/7, that's 2/14, which is 1/7. Okay. Now let's look at this one. So a bag contains 8 red crayons, 14 purple, and 6 yellow, and 4 green. A crayon selected, replaced, then selected another. Find probability of each. By the way, it's crayon, not crayon. But anyways, so probability that's purple. Well, first let's figure out what total we have. We have a total of 32 crayons. So the probability that it's purple, that's going to be 14 out of 32. The probability that it's yellow, because you put it back and then you draw a yellow one, would be 6 out of 32. So if you multiply that together, you end up getting, and you reduce it, you end up getting 21 out of 256. Okay, green and red, green then red. So green is 4 out of 32, red is 8 out of 32, which ends up equaling 1 out of 32. 2 purples, 14 out of 32 times 14 out of 32 will end up being 49 out of 256. 2 yellows, 6 out of 32, 6 out of 32 ends up being 9 out of 256. Okay? Now, we have the same crayons, but now they're dependent. So you draw one, and then you don't replace it, and then you draw again. So the probability that you choose a yellow, then a red. So the yellow is going to be 6 out of 32. But now we only have 31 crayons to pick from. So now to pick a red, we have 8 out of 31. Which ends up being 3 out of 62. Purple, then green. So purple is 14 out of 32. Green is 4 out of 31, which ends up reducing to 7 out of 124. To reds, that's going to be 8 out of 32 times 7 out of 31. Will end up reducing to 7 over 124. To greens, 3 out of 32 times 4 out of 32 times 3 out of 31 equals 3 out of 237. Okay. So this one, we want to know a card is drawn from a standard deck, not replaced, and another is drawn. What's the probability of choosing a heart? Well, the probability of choosing a heart is 13 out of 52. And then we want to know the probability of choosing a spade right after that, and we didn't replace the heart. So it's 13 out of 52 times 13 out of 51, which is going to be 13 out of 204. Okay. This one, Jack has 4 Snicker bars and 8 Mars bars. He randomly chooses a piece of candy, eats it, and then chooses another. What's the probability that both candies are Snicker bars? Candy bars are Snickers. So that's going to be 4 out of 12 times 3 out of 11, which ends out reducing to 1/11. Okay, I'm really, really sorry for how late I put this up. You guys are awesome. Again, sorry. Okay, bye.